Hello, my name is Chris Ellis, and this is code review for CS499. I'm going to be talking about three separate code artifacts for the final project for this class that cover three categories of enhancement that will be made. Category 1 is software design and engineering. Category 2 is algorithms and data structures, and Category 3 is databases. I do not have three separate artifacts for these. I have a single artifact that covers Category 1, software engineering and design, along with Category 3, databases, and then a separate artifact that covers Category 2, algorithms and data structures. First, I'll be going over the artifact that covers Category 1 and Category 3, since there will be overlap in the review portion of this. That overlap will cover the existing functionality of the artifact, along with the standard code review checklist categories for that artifact. And then after that, I will diverge and talk about the enhancements that will be done for both of those categories for this artifact. After which I will provide the same review of functionality along with code review and then enhancements for the second artifact that's covered by Category 2, algorithms and data structures. So if I open IntelliJ here, the first artifact we're looking at is an original assignment from CS320. This is the automated testing and quality assurance class at SNHU. And this assignment was the final kind of collation of multiple assignments where we had developed Java classes and services for appointments, contacts, and tasks. Each of these specific services implements a different functionality. The appointment functionality implements storing appointments. The contact service implements storing contacts. And then the task service implements storing a task type object. All three of these do not have overlapping code. They don't call into each other in any way. They're functionally the same underlying structure of code, just for the different specific objects and data structures mentioned. Along with the underlying class for each of these and the implemented service, there are tests for both the class and the service for all three of the different class types. So to begin looking at kind of what this code does, since they are the same, I'll take an in-depth look at one, which will be the one that is mostly relating to my enhancements that will be done later. And then I'll kind of go over the differences to remove redundancy in reviewing the code of the other types later. So we'll look at the task classes. If we just kind of go into this class, it's got some private variables in the task object type, a specific constructor. Scrolling through, there are standard getter and setter functions. So we may have like get task ID, get name, and get description, along with set task ID, set name, and set description. This is an extremely basic example, and the reason the library is implemented in this way was less to write advanced code and more to focus on testing. The tests are written to use JUnit, and specifically we wanted to have an object we could look at and then a separate service for the purposes of testing, so that we could look at more advanced testing along the lines of validation of any input that may come from a user. In this case, it's not coming from a user. All of the input is run through the test cases. There's no main function for any of this code. So we'll look deeper into the functionality of the task class specifically. This object, obviously we just went over, has these private data members and getter and setters. The actual meat of the operations are stored in the task service. The service is a class that's designed to store multiple tasks. It stores them in a list data structure. This class, the task service, also has a constructor which creates a new array list when the object is instantiated. And then it has the same, as there's only an array, it doesn't have getters and setters for private members, but it interacts with the underlying task class to add and delete task objects from the array. And they are of the type task, which we looked at in the previous file here. So these objects are this class instantiated in the service. And then we can see there's an add task, delete task, get task by ID if we want to find one task specifically and we know its ID, along with a check is task unique ID. It's kind of a utility helper function. An update task name if we want to change the name. We need the ID as an input, along with an update task description as well. And then the only getter we need is to get the entire list of tasks. This is kind of the underlying skeleton of code. The contact and appointment services are implemented in the same manner. There's an underlying appointment and contact class that creates the object. There's a service that manages the objects. And then we'll see later, the only real difference is the data structure itself and the types instantiated in the members. For our task, obviously, we can jump back here and see that we have a task ID, which is a string, a name, which is a string, and a description, which is a string. If we look at the test class for our task, which is the actual object, we have some variables that define specific test data for the tasks. So this is the valid constructor variable. We create a task. And then we have some valid task data. So we know this should not fail to construct based on what we expect our constructor to take. We have some invalid task data, which is common for tests, as we often want to reuse the same invalid data for multiple tests of the same type. And having all of this data as a global variable for the size of this test is okay. There are advanced techniques beyond this for large tests across large programs, such as including parameterized input or entire mocks of objects that can be passed in. For the simplicity here, they're not incredibly complex class files, so we didn't need any of that. Functionally, our test here calls set up a valid task, as in we have a task service where we want to add and delete tasks. We will be reusing this set up a valid task function more than once. If we wanted to say add 3 tasks, we might call this multiple times in tests. This actually has a specific decorator before each. So it runs before every actual test case, along with the after each function in JUnit, which will tear down any data we need. This is used to clean up tests so we don't have excess things sitting in memory. Were we to run longer tests. This test will first test a valid constructor. These display names are kind of nice to have, especially in IDEs. Like I'm using JUnit here, but in Eclipse as well, when you run the tests, which we will show as well, it will mark them all with their display names, so you can see which test very easily is failing or passing. It's all wrapped in a function so that it can be easily called. And this test valid constructor has some assertions here. and it checks that the getter functions of the created object, get task ID, get name, and get description from our created valid task, which is created in this before each section, is equal to the global variable that we set originally in this file. We have some specific SAD path test cases here. So we test a constructor with a task ID that's longer than 10 characters, where the test is invalid when the constructor has passed too many characters for a test ID. And we can see we expect a specific illegal argument exception to be thrown from this. That's the passing portion of this test, is that we get that specific error out. We test the constructor with a null task ID, which is also a SAD path case. We test valid set name outside of the constructor, and we test valid set description outside of the constructor. This is just to test the setters that are part of this class. And then we test invalid entries for setters specifically, the same way we tested the constructor. We want to test all of the setters with their expected invalid values to make sure they return an illegal argument exception or whatever error they're specifically looking at. And then we test the getters as well. Since we looked at the task file, it was a class with a constructor and getters and setters. This is complete coverage of all of the tests. And I believe during the class we ran code coverage. I don't have the IDE settings for that now, but all of these tests had a requirement of having 100% code coverage in them. So we exercise every known path, and that's kind of the reason why the original tasks were kept simple. Task colloquially, and not the specific task here. It's the same for the appointment and contact services. If we look at the last piece of a task implementation, it's the service test. We create a task service, and like our last test cases, we have specific tasks we set up. In this case, we set up 3 for testing to have an idea if more than one task will work. We set up a valid task service, which is passing constructor information we know, and then we use our new tasks to populate it. This is in the before each that runs for every test. And then we have the same teardown where we set task service equal to null to kind of clean up everything afterwards. So for the service, we want to first test that we can add tasks that are valid, that we know are valid. And then in these, we'll create a task. In this case, we already have the tasks pre-created. It's task 1. We will add that task to the service. We will call get task list on the task service to return all of the entries to the array. And then we will assert that the size is equal to 1, as we only added 1 task. That should be true. And then we will assert that the task 1 object we created earlier is equal to the 0th index of the list, which should be task 1, that they are the same. We test adding multiple tasks in this case. We perform kind of the same checks for this. We check that the size is equal to what we added, and that each task by index, because we've added them in specific order to an array, matches the one we expect. We test deleting a task. In this case, we add a task 1 again. We assert the size is 1. We then delete task 1 by ID. And then we check that the task with that ID no longer exists. And in the return path for that code, we expect it to throw an argument, so we catch the argument. And then we, as another check, ensure that the array is empty when we're done. And then we begin testing the other functionality of that class, including get task by ID, updating task name, updating descriptions. These tests specifically function exactly the same as the other ones. There's not much more logic going on here that's different in terms of the functionality. And then we test some kind of sad paths, as in adding a task when one already exists. We catch an illegal argument, which is that task already exists. We test that delete throws an error when the task we're looking for is not found. We test that update when the task ID is not found also throws an exception, and then the same for update description. This functionality for the task unit itself, which I'm talking about as a unit, the object, the service, and then all of the testing of that, is functionally duplicated across the contact and appointment along with their services. If we take a look at the appointment class, we can see it's functionally the same object as a task. It's just the same data structure. It has a few private members, a string ID, a date for appointment date, and then a description for string. So we can see this is functionally the same as a task, except it has a date member instead of all string members. And then a contact service has more members in that it possesses an ID, a first name, a last name, a phone, and an address. However, these are all strings. If we did take a deeper look at these later, we will see that there is some different code going on in the logic, but due to the repetitiveness, the objects are the same. They kind of all do some input validation, and then all of the tests are the same. So the appointment, contact, and task service all kind of do the same thing under the hood for their specific data structures. Next, we kind of want to look at the existing code using the relevant code review data, checklist. This checklist begins talking about the structure of the code. And since we don't have the design files, we're kind of going based off of what we're reading here, but I think these classes are simple enough. We can kind of reason about how they should have been designed. There's no crazy data structure abstraction going on. It's just they're all their own specific class object. The class object itself has private data members. It has a constructor, and then setters and getters, which is standard in Java. Most of these are actually probably auto-generated by an IDE in many cases when you're writing the code, so it's pretty standard, and we can say that this code is following the standard structure, since if you generate code like this, it looks exactly like this. In terms of consistency and style and formatting, we can see this is due to the IDE auto formatting, that everything is the same. All the tabbing is the same between contact and appointment classes. The spacing is the same between new members. The parameterization is kind of laid out the same. There's only 3 parameters here. It's not many columns. I mean, this is 90 columns. If we look at contact, which may have more fields, we're at 105 columns. I think many people kind of set their editors to 120 columns in this day and age due to widescreen monitors. So there's no need to break this up onto multiple lines for the input. We can see here that we set line by line. This line would have been longer than above, kind of spread out, so it's a little bit easier to read that we're just calling in the constructor a bunch of setters. There are short comments above these getters and setters. The commenting for this I don't think is strictly necessary. I think it's good to have comments for what functions are doing if it's not completely obvious. Getters and setters are kind of a construct in Java that's so prevalent. I think the comments are a little redundant to have here. But having them isn't a complete negative. It also lets us confirm that our comment actually matches what the setter is doing. So we're setting the setter for address with validation. So we should have a setter set address that has validation in it. The other thing the IDE is helpful for code review like this is seeing if there's unused members. So if we kind of want to look really quickly, if we add a test member of type string, the IDE will actually be showing us that it's never used, which is very helpful in reviewing. So we can see all of the members are actually used. This is confirmed later by running all the tests, since they cover every path in the code, but it's a good fallback to have the IDE also check that for us, or to run things like linters that may catch these things for us. You can see we have a squiggle here. This is throwing we throw an exception when the parameter is null. That's by intention for the assignment. That was a requirement, I believe, when we wrote it, which is why that explicit check is there. If we look at any of these, I'll return to the task services for this part of the review. We do not have any kind of blocks of repeated code specifically in the class files. The closest thing I would say in task when we were looking to some repeated code is maybe these checks where we're checking if task ID is null, or task ID.length is something. We could put the null check into a function since it's reused a lot. I don't think it's strictly necessary for this either. It's almost to the point of abstracting a lot more than we need to. I think reading through this, we get a very simplified view of like, here are the members, the constructor, and then methods that are on this object. We can see that they're public. They're return types, and line by line with the single comments. It's short, simple, and easy to read through. And I think structure-wise, this works pretty well. One thing that we may want to look at, especially in the task itself, is this task ID.length. Not necessarily that we may want to abstract it into a function, but this task length that we're checking against could be considered kind of a magic number. The same with name length. We may want to pull these invalid inputs into their own variables for clarity to check. I think it's a little easier to understand if we were to pull them out instead of saying like, well, we throw an error when task ID is null or it's longer than 10 characters. Well, why is it 10 characters? If they're magic numbers, we can kind of also include some documentation as to why that may be the case up there, which could also be included in these functions here, but is not necessary at this point. If we look at the actual test code, one of the issues with writing test code is there's often a lot of boilerplate that's repeated. I think part of the task in this class is to kind of reduce that boilerplate. We're doing it by setting up some global variables here, and then reusing these variables in the before each and after each functions here that are decorated as setup and teardowns. This reduces a lot of the boilerplate. Otherwise, for each test, we'd be calling the same valid task every time. And then editing this, let's say we added a new parameter, doesn't require us to go into every single, when there could be hundreds of tests, test to edit that. I think we can see in this case actually that we have a variable invalid task ID null that is never used. So that would be something we would want to look at and see why this was never used, whether it's whether the data was generated from a contract that we actually don't test, or the underlying code doesn't test this anymore. Especially in a test, this is a code smell to me that there might be something we want to take a deeper look at. Invalid task ID being null. So we can check our tests here. We have a constructor, valid constructor. We test constructor with a null task ID. And we try to create a new task where the task ID is too long. And if we jump to this definition, we can see that this is likely a copy and paste error in the tests that wasn't caught. Our invalid task ID too long was used in 2 tests where it probably should only be used in 1. Task ID is too many characters. This is the correct area for that test. Invalid task ID too long here should likely be invalid task ID null. That will fix our unused member. And then we will rerun the tests kind of after I look at the service tests. And go through the rest of the code review. Documentation-wise, there's no documentation in this as part of the assignment. There's no README or anything for how to run this. We don't even include, I believe, due to the ID in the class being Eclipse, reusable test runners. I've recreated a test runner in IntelliJ here that we will use to rerun the tests to kind of demonstrate how they work. The comments for this code seem pretty consistent. They're a little redundant due to the simplicity of the assignment. I think these are kind of good placeholders to see what our code might look like commenting-wise in the future. If we look at this longer comment here, we can see the setup and tear down of valid constructor for each test to use. Invalid constructors are initialized explicitly in invalid constructor test methods. So we know that every valid constructor call will be set up using this before each. That's some code reuse. And then we don't create invalid constructors automatically. We do it explicitly in those tests, likely because there was only 1 or 2 cases of that, where we had testing in a larger case. We may also want to abstract that into decorated methods like this. These are before each, so it runs against every method. It doesn't mean you have to use it in the method, but it's a little kind of a clumsy mechanism to use before each because it applies to everything in the file. You can use specific parameterizations and wrap things in like a function, say like create invalid constructor function and just reuse the function as a decorator using some other features of JUnit that weren't necessary here. I think looking at the variables next, we can see that all the variables are defined in all of these in the appointment, the contact class, and the task class. All of the members are private. They all carry their specific return type. They're given good names, having something like a task ID and then a name and description is reminiscent of normal data models that we might use in an actual database, even though this code doesn't use a database. The variables are kind of already set up to do that for us, which is nice. It makes it easier to understand instead of us having no ID here and just a name and description, which might work for our limited case here. But then were we to expand, as I will for the enhancements, it's more code that we have to add to make a functional underlying library unit that's already here. And the variables for these are pretty well defined. If we look at a contact, there's an ID, a first name, a last name, a phone, and an address. We don't have a bunch of extraneous data. This is kind of the bare minimum I would expect for a user of, say, a website, maybe an email, if it's specifically a web app. If it's just a contact, most people generally store their contacts with the phone number, first name, last name. Even address may be like kind of an optional thing depending on what you're doing. For an appointment, we have the ID, the date of the appointment, and then a description. I think this is actually a really good layout. It's incredibly simple, and that makes the testing simple. Especially testing around dates can get very confusing, date implementations, because there's so many libraries that can handle it. Conversions between dates and time zones get complex. Keeping anything with a date as simple as possible when you can is a good thing. I don't believe there are any explicit arithmetic operations we need to look at. Most of them are validity checks in this, where we're checking a length against. These are specified magic numbers, but we should make it specific as to why we would be validating these numbers in documentation at this specific value. Generally, this will be based on the maximum length of what we're storing in the database. So if the contact ID is a specific length of string, we would limit, or we would want our validators to check that so we don't run into errors inserting into the database. It's easier to catch it earlier in the code than to get to the query point when we're inserting things in the database. Next, we kind of want to look at the loops and branches. So any looping would be done in the services due to their array that is their underlying data structure. I don't believe this code has much looping. It would likely not be in the add task. We would have some in delete task as we iterate through looking for the specific task ID. This is a side effect of using the array as the underlying data structure, where this a hash table, we could just check by hash, probably by ID underlying here. So we set up an iterator. We iterate through each task, where we set the next task as the next iterator object. And then we check if the getTaskID function returns the task ID we're looking for to delete. If the entire loop runs through and we don't find it, we assume it doesn't exist and is not found, and we return the illegal argument exception. As far as modern Java goes, using an iterator like this is the best practice we can get. This helps us avoid out-of-bounds errors, as we're not guessing at the size. We don't need to perform any sizing checks on the array to ensure we're not going to iterate past the end of it. We just iterate through each object in the array, and then when there are no objects left, we exit. This removes a whole class of kind of bounds checking we have to do, which is a very big case of bugs in a lot of other code. In the public getTaskById, this uses a simpler for loop to go through this. And we check against the private member tasks, which is the internal list object. We functionally do the same thing. We loop through. If it is not found, we say it's not found. I don't recall if this was a specific implementation issue. These loops functionally can be the same thing, I believe. There's no reason we shouldn't be using the modern iterator methods when we have an iterator to use, as far as using Java. It may be for that getTaskID is so simple, we're literally just looking for the task ID, although up here for delete task, we're kind of just looking for the task ID. This was likely implemented using the iterator. I think as we're reviewing it, we can kind of try and reason about the design. Probably using the iterator so that we don't have to figure out the index or track the index to remove it, as well as look at the resizing of the array to change indexes or anything. We just remove it where we're at and then exit. Whereas we don't need to do that in getTask, so this code's a little simpler and easier to read. I think it'd be better to consistently pick one of these here and just say, if we're going to be using iterators, just use the iterator everywhere. It makes it a little easier to reason than like now we're looking at this wondering why it's a for loop and not an iterator. And although we've reasoned about it, had it been an iterator, we would have just probably scrolled right past it, be like, yep, that's the iterator, same check, same thing, it looks good. The same here. It's another for loop to check if the task ID is unique. It loops through looking for an existing task ID. Looking at this code now, this was part of the implementation, was to use an array, I believe, or array list as the underlying object. This would likely have been better implemented as a hash table due to all the validation checks, where we could get an O1 time complexity to look up an ID for something instead of looping through a list. The lists are so small it doesn't matter, but again, when we're making an enhancement like building an app around this code, where we're having a large number of tasks, we may actually need to consider that the loops take time to go through thousands and thousands of tasks versus checking in O1 for a hash lookup. We don't really have too many logic checks here or branching. We have obviously this check in the iterator that we've reviewed already. We can look at task ID here. We say it's a basic Boolean check. If the ID equals the ID that's the string input, then we return it. If not, we return that it was not found. That's the same here. So when we're looking at the tests for this, we would want to check that this happy path returns a task. Otherwise, we return an illegal argument. We kind of looked at this earlier, but I'll go back to the tests to look at it again. So looking at the existing loops and branches, I think that's all we have in here. Get task list will return the entire array list, so there's no looping through in that function. And again, we'll kind of browse through the services for appointment and contact. Specifically, these won't actually be used in the enhancement I'm doing. The task service is the focus of the enhancement, which is another reason I won't go as in-depth looking at these. We can see we have the same type of iterator almost exactly here for delete contact. Get contact is the same type of loop with the Boolean check. The updates are just finding the contact and then updating, which is the same as our other class as well. We check, is the contact ID unique? It's also a normal for loop with the Boolean check, returns false. If the contact was found, and true if the ID is unique. This code looks like it may be redundant with some other code. And it's a little different from the structure of our existing code where normally we're returning an exception instead of true or false. I believe that is because in the design, this specific function is used as an underlying check. Yes, it's used as an kind of a private method inside the class for add task, where it needs a truthy value. It's not like the external methods that are called by tests where we're expecting an argument. So that's kind of expected there. It might make sense to put some comments here to clarify that a little more. And then kind of looking at the appointment service, this is the same thing. We have a list of appointments. Add appointment is the same kind of logical check. Delete appointment uses the same iterator style. Same get appointments. The is appointment ID unique is exactly the same as our contact and task checks. And I think looking at the loop conditions more closely, we kind of want to look and see if they all have explicit exit cases, like a while loop here. We want to be careful to make sure that this exits versus a for loop that, say, this for loop, especially with a for loop over a specific object that's an array list, should exit. The array list isn't going to be infinite. However, a while loop may be infinite, but we're using iterator.hasNext, which, if we look at the IntelliSense here, tells us kind of how this operates, and it returns true if the iteration has more elements. So this is kind of letting the language handle it for us, and we can be reasonably sure that we don't need to perform any extra bounds checking or anything. That this method is basically going to check for us and will exit early if it needs to. Lastly, we want to look at some defensive programming methods in here, and we'll tie this kind of into security as well in this code. We've looked at some of the validation already, specifically around tasks. All of these constructor methods in their setters are validated. There's minimal validation here. We're checking that to make sure it's not null and that its length is a specific value. The same with the name being under a specific length and the description being under a specific length and isn't null. These are kind of minimal checks that we want to do. There may be more specific things. We're looking, if the description is null or it's longer than 50 characters, we throw an error. But we might want to be checking for, is it shorter than a specific amount too? Or any kind of more detail. At this point, the code's so simple, there's not like a bunch of other checks we would really need to add. This gives us coverage kind of the basic inputs. And it's important at every level of our code, including the task class and the service class, to kind of have these built in. Since the service is just operating on tasks, it won't have as many validation type scenarios. But even if we look at our add task, we call a function to check that it's unique in the data structure. And for delete task, we're checking and handling an error if it's not there. We have the unique function that's used in the add method. The update methods, these could probably be improved. They kind of rely on the underlying task to handle input validation. And due to defense in depth being a strategy we want to implement, we would like to implement that same kind of validation at every level. If we're taking input from a user, which this class is only taking input from a test, but in theory, the service is what is actually being called by users of this library. They're not actually setting underlying task stuff themselves. The service itself is managing it. We would want kind of validation at every layer, especially, and this is specific to my enhancement later that I'll talk about, is tying this into building an API or a web app where we want to validate input that is from a user at as many levels as we can in order to ensure that we're not feeding possibly hostile input like a SQL injection through anywhere in our code. And the more places we can check that, the better. And that might be as simple as writing reusable utility functions where we have specific validations in. There are libraries in Java built for doing these type of validations. We likely want them on the endpoint where the user puts data in, the REST endpoint or the UI, as well as having it in our API and classes in case, one, those checks are wrong at any place. We'll probably throw an error and maybe find a bug. But in terms of defensive programming, we don't want to do it just at the lowest level. We want to kind of do it everywhere. We have seen that the imported data, kind of all of this input data to the service and task class, all have, although minimal, have validation. It covers all of the paths we're expecting in this simplified code. We don't have any unassigned variables or unused imports or unused variables sitting in our classes other than the one we kind of looked at and made a small fix for in the test cases. Although the test cases are not underlying code, so we're not as worried about them, but we want to make sure our tests are robust and actually cover what we're looking for. And we don't use any specific other things that may need to be added if this code was expanded. Again, it's very simple. We're not calling out to any databases currently or external APIs, which would require much more robust validation and error handling. One, like I said, to reduce injections or the ability of a user to inject code. The other being that we don't want to, or sorry, that we do want to look at anything being passed between classes and validated as well. So we kind of have gone through this, looked at the basics, found a couple problems that we might want to fix. I'd like to go over my enhancement for this now as well. And my plan for the enhancement here is to take just the task code. Because of the redundancy between these, I don't find it necessary to use all of it. We would like to look at the task code. And I'll run the tests actually real quick to demonstrate that all the tests are passing, and we can see the descriptions. So this is a very usable library in its current state. It's not actually used except by the tests. So my enhancement is I would like to take this and expand it into a full stack web app. I would like to kind of branch here now and talk about the full stack web app enhancements for the software design and engineering category. This code I will likely rewrite into a language that I'm more familiar with to use a web framework for to develop a full stack app. Python or Golang, I have not decided, and this was specified in the design docs we've handed in. So porting this code to, I think Golang or Python is pretty easy, as Golang is simple and Python is object-oriented. It looks like a less verbose Java code. I don't think that will be an issue. We'll likely need to do server-side rendering for the UI. So I'm only going to be taking the task service, and building a full-stack task manager. But in that case, we already have the underlying skeleton of a library for tasks, a task service for handling it under the hood, and a full set of tests that should be pretty easy to convert in place. And as part of the enhancement, after conversion and adding server-side rendering for the UI, we will also likely, depending on time, add features, which may be more fields, but we already have a good outline for what the classes will look like and how our tests will look, and everything else that kind of goes with that. And specifically, the skills that I'm looking at aligning in this category are sorry, I'm just finding the documented things. The specific outcomes that I'm kind of looking at are employing strategies for building collaborative environments that enable diverse audiences to support organizational decision-making in the field of computer science, and design, develop, and deliver professional quality oral, written, and visual communications that are coherent, technically sound, and appropriately adapted to specific audiences and contexts. This is just the nature of the full stack app, from design through the SDLC, the design, planning, layout, from writing diagrams to design docs to architecture docs to writing the code, handling comments, adding tests, test documentation, run documentation, readmes. All of this covers both of those cases. And in addition to that, I would like to talk about the second category, databases, which I will be using the same artifact for. We've mentioned building the full stack app that will use the underlying task and task service along with tests to build a task manager. This information we've seen in the tests here is all stored in code. The actual objects store nothing themselves. We'll be adding a database interface in the full stack app. So tasks here, it's an array, but we'll likely have an underlying hookup, depending on the implementation, to a SQL database. This will involve developing a data model in SQL to go with this, as well as expanding on the code to have users so that we can have tasks for specific users, even if it's just the local computer user tied to an ID. This will require engineering skills like creating join tables in the database. In addition, we will be selecting a SQL database, standing up the SQL database, and building in seed files and migrations. So the full stack app will be taking this task code essentially, making a library in another language for it, doing server-side rendering to a UI, as well as adding a database, taking it from functionally a small library implementation to a full stack app with a front-end UI in HTML, a REST API for the back-end, which calls the underlying libraries to deal with managing tasks, and a full test suite to make sure all of that works, and the logic of the task service, as well as being able to write and store that data into a database. The database itself will also cover some more elements of the class's course outcomes. And it's related to the plan for Category 1. In this, since we're designing a data model, I have selected the demonstrate an ability to use well-founded and innovative techniques, skills, and tools in computing practices for the purpose of implementing computer solutions that deliver value and accomplish industry-specific goals, as well as develop a security mindset that anticipates adversarial exploits in software architecture and designs to expose potential vulnerabilities, mitigate design flaws, and ensure privacy. These are important to cover, I think, in the database design, especially looking at the OWASP top 10. Injection attacks are often at the top, and injection to the database, specifically SQL, is a common vulnerability that's found. In addition to the existing tests, we'll be adding tests, and there will be a lot of hardening and input validation, as we've seen, but to a bigger extent in relation to the SQL database, as adding that category as part of this project. That's kind of it for these first two artifacts. We'll be moving on to the final artifact. This one will be less verbose, as it is a much simpler program. This is Android Studio, and this artifact is for the Algorithms and Data Structures section. This existing code is an Android application with very minimal functionality, so we only need to actually look at the Java source here and look at the main activity. The rest of this code, other than some of the auto-generated resources, is boilerplate from the Android Studio, in which case we don't need to review it. It's not relevant to our main code here. We'll kind of hide the imports up here. This app's function is to read accelerometer data from the phone's sensors and display that data. That's all that this app does. when we run it. And this was kind of a specific thing to look at the APIs for accelerometers and sensors. That's why it's so simple. And I'll kind of jump into the review for this one since it's so simple. But for anyone not familiar with looking at Android Studio, we have a main activity. This is an activity in Android is kind of what happens when an app starts. So our main activity is like a main function, but just the main UI page for an Android app. It extends some existing app compat activity, which is a generic class, and then we implement sensor event listener along with this private sensor manager, and then the private sensor specific for the accelerometer. These classes are how we tie into Android's access to the hardware to read sensor data. There's this onCreate method, which runs kind of at the start when an app fires up. An onResume method and an onPause method. These are kind of if you like swipe out of your app, it will pause, and then it will resume when the app is opened again. And then we have a method we've added called onSensorChanged, where it works kind of like video game code where there's an update function, and we basically have a listener that checks if sensor data has changed and then polls again for it. And that's kind of how the app functions. I do not know if this will work out of the box due to me not having running devices set up in this version of Android Studio. Okay, it looks like the app is installing. Okay, it is working, and we can see the kind of accelerometer data here. If we look, we could rotate the phone. Kind of lost our accelerometer data there. But if we look at the X, Y, and Z axis, this is where the phone is facing based on the input data. All it's doing is displaying. So we'll jump right into the review portion since it's so simple. We're kind of just looking at X, Y, and Z based on where the phone's positioned in space from the accelerometer. In onCreate, we enable the content layout. This is all UI specific code. This is actually boilerplate that's reused for kind of setting which menus are in here, the view compat set on apply stuff. We initialize when the app starts. This is Android specific. We initialize the sensors for the accelerometer and the sensor manager. And we can see in onResume, we register the listener when it resumes, and we unregister it when someone leaves the app. This is so we're not eating their battery, taking their power up when they're not using the app. And this is how we implement kind of only reading data when the app is open. Now, the meat of this code is the onSensorChanged poller, where it kind of takes in a sensor event, and then we look at the type. If it's the accelerometer type, we read the values for each axis. And if we look at the accelerometer type here in IntelliSense, we can actually look at the, I meant to look at the event itself. So we look at the sensor event. And we look at the IntelliSense docs. It's like a direct explanation that how the X and Y axis work and the Z axis for it. We read X is the 0 value of this list. If we look at this actual return value here, 0 is the GX on the X axis. 1 index of this list is the Y axis. 2 index is the Z axis. So we can kind of, they're not magic numbers to us, they're Android specific. We could probably hard code these into a global variable so we know what they are at the top, but It's common in Android code to just use this, and engineers working on it will understand it by looking at the methods in IntelliSense. We then have the accelerometer data. And then this is boilerplate view code to kind of update the view live as the data changes. So the meat of our code for actually doing this is kind of just look up these values, format them in a string, and then update our view. So as that data changes, we will kind of see this running. And I believe there's a method. I'm not sure off the top of my head where this was at. There was an orientation thing. I don't think we need to look at that specifically to see. But we'll kind of jump back into the structure review here. I think structure-wise, this is a lot different from the other Java code we looked at. But this follows the kind of auto-generated layout for an Android app. We have a main activity, that's standard. We have some global variables in the main activity. Due to the simplicity of this app, that's how we chose to do it. It's very simple. The implementation for this did not require writing tests, so there's no tests, there's no documentation. These are things that we would like to add, but this is a very specific assignment with a very specific grading rubric that was implement this to do this, and that was it. So it doesn't have a lot of the bells and whistles that like more advanced projects like the previous one had. But again, it's standard in Android to use edge-to-edge layout, and then use the set content view along with view compat to update what our UI looks like. And then we initialize the sensor manager and on create. That's standard. Having an on pause and on resume. This is actually good structure. These are built in. As you can see, we're overriding existing methods. Those are built-ins that we want to do our own logic in, and we're adding what we want to happen, but we're handling it in a way where we're making life better for the user by only doing our app updates when our app is open. Along with the on sensor changed, we're kind of overriding this to do our check and then write to the UI. And we update this when the sensor changes, which is what we want. There's not really a more efficient way for us to handle this, and it's very simple, so we don't really need to in the first place. We don't really have many variables to kind of look at. It's just the sensor manager stuff. Because there's no user input, we kind of don't really need to consider any security things around variables or validation for this, as we would in the last case. There's no real arithmetic operations. We're kind of just pulling values out and writing them to a string. And there's no explicit looping, although the on sensor changed is kind of looping for us under the hood. However, we can assume that this looping is correctly implemented as it's implemented by the underlying Android libraries that we're using. We kind of have to assume that. There's little to no defensive programming. This is a kind of another problem we have with this program is it was implemented to show a specific function, and it only does that. These indexes, as I said, could have been renamed. Otherwise, security-wise, there's, again, with no user input, there's not really much for us to look at. In terms of that, we should kind of be checking and validating things that we would pass between functions, but again, we're not really passing much between functions. We're just pulling values off a sensor and displaying them. And error handling wise, we don't really check for any errors from the sensors. This is kind of an area that should be improved. Were we implementing this with more time? adding sensor error checks and such would help us out greatly here. And it kind of maybe some sanity checks to ensure the accelerometer data is correct. In theory, we should only be getting back valid data. We might want to look up in the docs what valid data looks like for the accelerometer and actually check it ourselves in some cases, specifically in test cases. Or in the case where in my artifact, we might want to implement test data. We might want to scan the test data first and make sure it fits what valid inputs are, so that when we read it in, we know that it's correct. And the enhancement that will be done for this app is actually taking this basic layout of an app, so the app is already set up, and implementing a more advanced algorithm. Instead of just reading a sensor and taking the data out of the sensor and displaying it, I'm going to be implementing a pedometer algorithm. So there's a couple ways to do this. It's functionally looking at the accelerometer data to look for peaks and figure out when a person's taking a step. Obviously, there's many error cases where you want to rule out where a phone is moving but someone's not taking a step. So we'll be looking for things like finding a peak of a certain acceleration is the basic model, and then adding more onto that algorithm to rule out things that are not steps or noise from the phone bouncing in, say, their pocket while they're walking. This could be things like thresholds, where we're looking for peaks above, or time spans where like we expect a peak when a person's walking at a specific pace to not show up for another second. So if we see a peak at a quarter second later, that likely wasn't a full step and was more of the phone being moved around. This item for enhancements to the code based on what we've seen so far from the review, I think a lot of this is not going to be improvements to the UI code. It's going to be improvements to the algorithm of this section. But again, we can add in some of the improvements I mentioned before. Better commenting, documentation. I'm unsure if this artifact will have user input yet, so it may require more on top of what we have now to add user input. And then more defensive programming and security checks. If it's just going to be fed test data through the Android sensor features in Android Studio, this isn't really user input, it would be phone hardware input. And we're less worried about security in that case because the only people dealing with that might be like hackers trying to inject bad data, which we would still want to check, but is less a case of like direct user input we'd expect from everyone using the app. If someone's manipulating their hardware sensor, that's a little harder case for us to deal with. And I think error handling is going to be a big thing. Especially in a more advanced algorithm, there might be error cases we want to like not stop our code when we hit, but instead kind of continue. Like we hit a really strange high value, we might want to just kind of ignore it and continue. So we'll need error handling, not just throwing errors and panicking and crashing the app when we hit an error that we don't understand. We will, in this artifact, I would like to cover the other missing course goals, which are design and evaluate a computing solution that solves a problem using algorithmic principles and computer science practices. An advanced algorithm is a really good choice to do this. And implementing that in kind of Android on sensor data allows us to run a test on a real world use case to see how an algorithm that's advanced performs against real data and not just contrived test data, which to me makes it much more interesting to work on. As far as the code review, I think we've covered the review of the two artifacts and the enhancements and the skills I'll be demonstrating in them. We've gone through the code review checklist along with some specific security, talk about REST APIs, user input validation, etc. And the course enhancements that are expected to come out of this as well. And I think we've done a pretty thorough job looking over it. We've noted areas for improvement, areas that are good, and were I giving a review to someone in real life, kind of this would all be written down in a way that we want to present it as a constructive set of improvements, not like nitpicking small things like, oh, why did we name this thing X instead of Y? And again, going back to looking at some of these variables, that might be something we want to look at. We call these float X, which that is just the axis, but we may want to give these more descriptive names in a larger program, such as x-axis accelerometer. It's a little bit easier to understand for someone who's reading the code who's never seen it before. Although the scope for these is so local, we may want to leave it as XYZ and assume the reader knows enough about sensor events to look at, say, like the event sensor data and be like, I looked and I saw, oh, it returns X, Y, and Z. I think both cases can be made, but I think a little bit more thorough commenting in this to say what we're doing in each method, why we're doing this. Especially in reference to implementing an algorithm, we likely want a large amount of context given to the implementation of the algorithm. A lot of algorithms may have, I know this was a thing in some old code I've seen online from Quake 3, where there's a special, I think it's a hex magic number used to calculate an inverse square root faster. And the commenting around it is kind of funny. And it's like, they're like, why is this happening? Like, where did you get this number from type of thing? It's just a good example of like algorithms kind of make performance improvements that might not be clear to someone reading. They're not as often simple to implement as like a two-sum or any standard like check loop for duplicate type of algorithm. Advanced algorithms might do strange things to get performance gains, and we need to note that in the code as well as the docs in order to explain them to people.